Hi, class. Okay, for this next segment, we're going to talk about we're going to deal with some data, but we also need to talk about the calculation of expected frequencies. As a refresher, chi-square analysis, or chi-square as a number, represents the difference between observed frequencies and expected frequencies. That's what chi-square represents. So that means we need to know two things in order to calculate the difference between them: observed frequencies and expected frequencies. I'm going to use an example, a relatively straightforward, hopefully basic and easy example, to illustrate the calculation of expected cell frequencies. You may recall the first example that was given as hypotheses that would need chi-square to test. I then used that hypothesis along with the others to construct a contingency table. That first example was sex is independent of, not related to, poverty, sex and poverty. And sex was assessed as male-female. Poverty was assessed as at or below the poverty line versus above the poverty line. So this handout is a replication of that 2x2 table. Up at the top, you can see I've restated the null hypothesis in using less detail because it's my hope that at this point in time you're familiar with the hypothesis. The null hypothesis is sex is not related to poverty. And as you can see, sex is in the columns position, males, females. Poverty is in the rows position, at or below the poverty line, above the poverty line. Except this time, if you look closely at your screen, or better yet, if you have the handout with you, I've added some information on this contingency table, both within the cells as well as on the edges. In each cell, you see a capital O that is not a zero. Capital O, capital O, capital O, capital O. Capital O stands for observed. You also see O equals and then a number. O equals 20, O equals 28, O equals 22, O equals 30. Those numbers represent frequencies. The O represents means observed. Observed frequencies. So essentially what I've added to this contingency table are the observed cell frequencies for each cell. And again, as noted before in a previous YouTube clip, observed frequency simply means that's how the data fell. So, according to this contingency table, according to our data, there are 20 men who are at or below the poverty line. Men at or below the poverty line. There are 28 women who are at or below the poverty line. See? Women at or below the poverty line. There are 30 men who are above the poverty line. There are 22 women who are above the poverty line. Okay, so all I did there was note the observed cell frequencies. 20 in this cell, men who are at or below the poverty line. 28 in this cell, women who are at or below the poverty line. This cell, 30 men are above the poverty line in this cell. 22 women are above the poverty line. Observed is simply how the data fell. That's what our data said. So this is as if we had surveyed all these people and asked them two questions. What's your sex, or what do you consider to be your sex, male or female? And are you living at or below the poverty line versus above the poverty line? Now, there's some more information on this contingency table that I've also added that I need to point out. Hopefully it's fairly obvious. I've calculated the row totals for each row total, and row total simply means this value plus the value that appears in the same row equals, so 20 plus 28 equals 48. That's the row total for this first row. I've also added the row total for this row. 30 plus 22 is 52. The row total, 52. So I've added the row totals. I've also added the column totals. Column totals. The column total for this column is 50. 20 plus 30 is 50. I've also added the column total for this column. 28 plus 22 is 50. So I've got the row totals, simply adding the observed frequencies for the row and creating the total. And I've added the column totals, simply adding the observed frequencies for the columns and indicating the total. And I've also calculated the total. And using the total is a good way to ensure that you've done all your math correctly, because the row totals, in this case, equal 100. 48 plus 52 is 100. And the column totals also added together equal 100. 50 plus 50 is 100. So I've added row totals and column totals. Here's another handout. FYI, row totals and column totals are referred to as marginals. That's how they're often referred to in the literature, marginals. And the reason for that is that they appear in the margins, the edges, the margins or the edges of the contingency table. Getting back to this contingency table that we were working with before, where we have the observed cell frequencies, you can also see a capital E in each cell. Capital E, capital E, capital E, capital E. That E stands for expected. Next to the equal sign after each E, we are going to place the expected cell frequency for each cell. The expected cell frequency. We've already have the observed cell frequencies. Those are pretty easy to calculate. In fact, we don't calculate them at all, really. They're simply how the data fell. The expected cell frequencies are how the data would fall if there is no relationship. How the data would fall if there is no relationship. So how do we calculate the expected cell frequencies? Well, it's a pretty straightforward formula, but it is a formula that you need to abide by, and the formula is right here. Expected cell frequencies equals row total times column total divided by total. In other words, you need to do this for each cell in your contingency table in order to calculate the expected cell frequency. So for each cell, take that cell's row total, multiply it by that cell's column total, then divide that product by the total. Getting back to our example here. Luckily, I already calculated the row totals and the column totals. So now all I need to do is do the math and insert the correct number into each square next to each E. So for example, to calculate the expected cell frequency for this cell, men who are at or below the poverty line, I need to take this, remember it's cell specific. I need to take this cell's row total, which is 48, and multiply it by this cell's column total, which is 50, and divide by 100. This cell, row total times column total divided by total. Row total times column total divided by total. Do that for each cell. Row total, 48, times column total, 50, divided by total, 100. So we're going to do that for each cell. I'm going to do that for each cell and then come back with another segment displaying the expected cell frequencies. If you haven't already done it, why don't you do the same thing? Calculate the expected cell frequencies for each of the cells in this contingency table. You have all the information you need to do it, and then we'll compare when I come back with the next clip.